Let's start preparing for the AWS Solutions Architect Associate C03 certification. This lecture is the first lecture, and we will look at what Solutions Architect Associate certification is and provide a general introduction to the content that will be covered in the lecture. First, I will give you a general introduction to AWS certification. There are 3 levels of AWS certification. Specialty certifications are excluded here. At the foundational level, there is a Cloud Practitioner certification, which is an easy certification to obtain if you have a basic understanding of AWS services and cloud concepts. The next level is the Associate level, and the Solutions Architect Associate certification that we are preparing for is a certification that falls under this level. Among other certifications, the Solutions Architect certification can be considered the most basic certification. And for those who wish to obtain other certifications at the Associate level, it is recommended that you obtain the Solutions Architect certification and then become familiar with most of AWS services before preparing. The next level is Professional level. Since this certification requires more detailed architectural capabilities for design, it is recommended that you obtain the Solutions Architect Associate certification to gain an overall understanding and then gain some practical experience with AWS before taking on the challenge. According to the official AWS website, the Solutions Architect Associate certification is recommended for those who have previous cloud experience or an understanding of infrastructure in an on-premise environment. However, even junior developers without cloud experience or understanding of infrastructure can obtain the certification if they understand the concept of cloud and AWS services for each topic. In our lecture, we will provide a guide so that even those who have no experience in cloud and infrastructure and are lost in preparing for the certification can easily obtain it. Here is detailed information about the Solutions Architect Associate exam. We have a total of 65 questions to complete within 130 minutes. The passing score is 720 points or higher out of 1,000. The cost of the exam is $150. There are 2 types of problems. In the case of single choice, it is a problem of selecting one of 4 options. And in the case of multiple choice, it is a problem of selecting 2 or more options out of 5 options. Our course to prepare for the Solutions Architect Associate certification is perfect for those who want to get quickly certified in a month. We want to help you prepare for certification easily, even if you have no cloud experience. It is also a lecture that can help junior developers understand the concept of the overall cloud architecture. For those who already have cloud experience, we will organize AWS cloud services for certification into topics and provide tips for preparing and taking the exam. Our course does not provide AWS practical training but focuses solely on organizing concepts and solving problems to pass the exam. First, we will understand the overall concept of cloud architecture and systematically organize AWS services by topic according to the scope of the exam. After finish organizing the concepts, we will prepare for problem solving through solving practical exam problems suitable for each domain. We will also provide exam preparation tips and exam taking strategies. The exam scope for the Solutions Architect Associate certification is detailed in the following slides. This is the test scope domain according to the AWS official website. There are 4 in total. The first domain is about security. It is one of the most common questions at 30%, asking how robust AWS services can be used to respond to security threats. The second domain is about resilience. 26% of the questions asked how resilient and elastic application can be designed by leveraging AWS services. The third domain is about high performance. The questions mainly cover how quickly large amounts of data or traffic can be processed using AWS services, accounting for 24% of all questions. The fourth domain is related to cost, and it asks about how to design a cost-optimized architecture by efficiently utilizing AWS services, accounting for 20% of the total questions. To prepare for the exam, you should focus on studying which AWS services should be linked to which design domains. You need to study each AWS service according to the topic, and I will introduce the AWS service ranges of the 12 topics covered in this lecture in the next slide. Here are 12 AWS service topics that we will cover in preparation for the exam, grouped based on the official AWS website. Topics 1 to 5 are the most frequently appearing topics. This topic is the most basic topic for understanding AWS services and cloud services, so you should study it repeatedly and master it accurately. First of all, the first topic is Compute, Container, and Serverless. We will learn about the concepts and building systems of AWS services, compute, containers, and serverless according to the computing virtualization stage. The second is about the storage, and it is about storages that are used. The third is about databases. The fourth is about networking and transmission. We will learn about cloud networking based on AWS services and CDN services that distribute content around the world. The fifth is about security, identify, and compliance, which is about security, authentication, and auditing. In this topic, we will take a closer look at IAM, the most important service related to cloud authentication and security. For your information, IAM concepts and designs are applicable to other public clouds, so they will be helpful when you are directly responsible for cloud practices in the future. We will study the remaining topics one by one. The fastest way to obtain a certificate is to familiarize yourself with the 12 topics. To summarize how to prepare for the certification exam, the first thing we need to do is to have a general understanding of AWS services based on the 4 exam domains and 12 service topics. The service topic map for related services will be covered in detail in Lesson 3. Secondly, after understanding AWS services, I plan to solve practice problems and get a feel of solving real-world problems by figuring out which domain and service topic the problem is related to. For reference, there are practice problems on the official AWS website and on a dump site called Exam Topics. On this dump site, test takers are directly discussing whether or not the questions are correct. So I also recommend this site to those who want to solve additional problems. You can prepare for the exam quickly by expanding on the concepts within the service topic map, which provides content that appears while solving problems. If you check the official AWS FAQ for topics that frequently appear in practice problems and cover in-depth content, it will be helpful in solving difficult problems with high difficulty. The official AWS FAQ is very extensive, so if you want to prepare for the exam quickly, it would be a good idea to familiarize yourself with only the frequently appearing services or new services. This is the service topic map I mentioned earlier. You should study the 5 main topics in detail, and in Lesson 3, we will cover how to reference and learn the relevant service topics. Lastly, I'll give you some tips for solving problems or taking tests. First, if you find the AWS service name and recognize which service topic or domain the AWS service name corresponds to, you can get closer to the correct answer. Based on this, if there are options that are not related to the service topic and domain, please narrow down the options. Also, you need to look carefully at the numbers in the problem. In particular, you can get closer to the correct answer by checking the figures related to data volume and traffic, and thinking about the most appropriate AWS service and design for the scale. This concludes our first lecture. In the next lecture, we will provide a general understanding of cloud systems and a general introduction to AWS services. Let's start the AWS Solutions Architect Associate C03 preparation course. Today, in the second lecture, we will cover the concept of cloud and a general introduction to AWS services. First of all, you must be familiar with cloud service. Let's take a look back at the definition of the cloud. When talking about cloud computing, the term cloud refers to the use of invisible computing resources. Users access the service through central server computing resources, and this access is invisible to the users. Let's take a closer look at some of the key elements of the cloud. First, cloud computing utilizes centralized servers. This means that all data processing and storage takes place on a central server. This allows users to access high-performance computing resources without having to build them on their own devices. The centralized server may not be a single server, but may be multiple servers or multi-region cluster. This will be explained in more detail when we discuss cloud virtualization, AWS regions, and availability zones. Moreover, cloud services operate invisible to users. Users can use the service without worrying about complex backend processing or infrastructure. This provides the convenience of being able to use it immediately when you need it, just like using electricity. Third, cloud computing scales dynamically. Cloud services can automatically scale up or down as your need changes. For example, during peak traffic times, more servers will be operational, while during off-peak times, fewer servers will be operational. All of this allows for efficient resource management. These cloud services are provided over a network. Cloud services can be accessed from anywhere with an internet connection, giving users the flexibility to work from anywhere in the world. We looked at the concept of the cloud again earlier, so what are the core technologies that made cloud technology possible? It is virtualization technology. Virtualization technology can divide and use resources according to the user's needs. As you can see in the figure, server virtualization, for example, creates a virtual server that can operate independently using a designated proportion of CPU and memory on a single or clustered hardware. This means that one physical server can be divided into multiple virtual servers. Virtualization technology can be applied not only to servers, but also to storage and network devices. This allows a single physical device to be divided into multiple virtual resources, each performing different roles. These divided resources can be used by different users or different applications. In this way, virtualization technology enables efficient use of hardware resources. It also simplifies server and network deployment and management, providing cost savings, flexibility, and more efficient management of a company's IT infrastructure. These convenient cloud services are largely divided into three types: IaaS, PaaS, and SaaS, based on the virtualization stages we looked at earlier. IaaS is an infrastructure service. PaaS is a platform service, and SaaS is a software service. First, IaaS is the lowest level of virtualization. Here, virtualization primarily refers to virtualizing hardware resources. Users install and manage software themselves, leveraging basic infrastructure such as virtual servers, storage, and networks. For example, you can create a virtual machine and run the software you need on it. PaaS is an intermediate step of virtualization. Here, virtualization provides a higher level of abstraction. Users are provided with a platform to develop and deploy applications. This allows users to develop and run applications without worrying about infrastructure such as servers, storage, and networks. For example, a developer can use PaaS to create code and upload it to the platform to run it. Examples of AWS services include RDS, DynamoDB, and Lambda. The distinction between IaaS and PaaS can be confusing, but the biggest difference is the scope of what you delegate to the cloud provider. SaaS is the highest level of virtualization. Virtualization here means virtualizing the software itself. Users get everything they need to run their application from the cloud provider. Users simply use the application and manage their data. For example, SaaS solutions such as Gmail or Office 365 are services that users can use through a web browser without separate installation or setup. Clouds can also be divided into public and private clouds. Public clouds are managed by external vendors and provide flexibly scalable resources as needed. It follows a pay-as-you-use model where users use as many resources as they need and pay only for what they use. These characteristics make the public cloud an ideal choice for scalable and cost-effective computing. A private cloud is a cloud environment dedicated to a single organization. This can be managed internally or by a third party, ensuring high control, security, and compliance. Private clouds are primarily suited for organizations that require strict data security and control. As the cloud becomes more widespread, the number of providers providing cloud services has also increased. Each cloud provider has different main services, and these days there are many cases of combining and using various cloud services to avoid being dependent on a single cloud provider. Have you ever heard of a multi-cloud strategy? Among the strategies that utilize multiple clouds, there are also concepts called multi-cloud and intercloud. Let's learn more about this. First, multi-cloud is an approach to optimizing costs and mitigating risks by using different cloud providers. By using multiple providers, you can leverage a variety of resources without being dependent on a single provider. However, these services are not integrated, so you need to manage each provider's services separately. Next, there is intercloud, which is an architectural approach similar to multi-cloud. Intercloud also uses multiple cloud services and integrates these clouds to support seamless interoperability and complex workflows. It integrates services across multiple cloud providers, allowing users to work in a single integrated environment. This enhances enterprise flexibility by supporting advanced data sharing and disaster recovery strategies. While multi-cloud optimizes costs and improves flexibility by using multiple providers, intercloud has the advantage of integrating various cloud services to improve interoperability and simplify complex tasks. Earlier, we looked at what the cloud is in general and the types of clouds. Now, let's learn about AWS, the certification we are preparing for. According to Gartner, AWS market share is approaching 40% as of 2022. It's the #1 public cloud. The growth rate is also overwhelmingly high, and the sales volume of the entire cloud market is also increasing tremendously. Most companies are accelerating their transition to the cloud. Moving to the cloud can enable agile development and dramatically increase productivity. We also need to quickly get AWS certified and join this rapidly accelerating cloud market. There are 5 important concepts in AWS. Let's take a look at the AWS shared responsibility model, regions and availability zones, pay-as-you-go pricing, designing for failures, and the best practices framework, which is a well-architectured framework recommended by AWS. First, let's talk about the AWS shared responsibility model. If a hardware issue occurs while using on-premise, the user is responsible for performing sound recovery work. If we use AWS and there is a hardware problem, AWS takes responsibility and repairs it. As you can see in the picture, AWS is responsible for the basic infrastructure, including region, AZ, edge location hardware, AWS global infrastructure, and the software that fundamentally supports this infrastructure, such as compute, storage, database, and networking. In this case, the user's scope of responsibility will vary depending on the service used. But since the user only has to operate within his or her scope of responsibility, the workload of managing the system will be reduced. For example, there are things like the data you use, the security of that data, and the handling of traffic that occurs on top of the architecture you configure. Let's take a look at AZ, which are regions and availability zones. AWS has a global infrastructure. This global infrastructure is divided into regions around the world, and these regions are called regions. At the time of this lecture, AWS has 33 regions. Each region has multiple availability zones called AZs. Each AZ is physically separate and has its own network and power source. AZ within the same region have high-speed networking, and data is transmitted in encrypted form. So, if a specific AZ in a region fails, the service is provided from another AZ in the same region, enabling uninterrupted service. An AZ has one or more data centers. From the AWS user's perspective, since the data center is not visible, it seems that you only need to focus on the concepts of region and AZ. AWS, like other public clouds, follows a pay-as-you-go pricing model. There are 3 advantages to a pay-as-you-go model. In terms of cost effectiveness, you can secure budget flexibility and avoid over-investment by only paying for what you use. In terms of scalability and responsiveness, you can reduce the risk of over or under allocation of resources by adjusting resources based on real-time demand rather than forecasts. This flexible cost management allows us to focus on innovation. Streamlining your procurement process can help your business prioritize innovation and adapt quickly to change. Each AWS service has a different billing system, and there is information about the billing system that appears on the exam, so we will take a closer look at the billing system for each service in a later lecture. Here's a design that anticipates the obstacles. AWS designs with the assumption that failures can occur at any time. By distributing servers across multiple AZs, you can provide uninterrupted service even if one or more AZs fail. There are also services that automatically deploy to multiple AZs or expand data areas, such as S3, a storage service. Finally, AWS presents a best practice called Well-Architect. There are 6 operational excellence: security, reliability, performance, efficiency, cost optimization, and sustainability. You can see that it maps to some extent to the 4 domains that we examined in Lecture 1. This is the scope of the test. It would be helpful to refer to the documents provided on the official AWS website below to prepare for the exam. Since the content is extensive, we recommend that you only look at the necessary content while solving the problems in order to obtain the certificate quickly. This concludes the second lecture. In the next lecture, we will look at all the AWS services that appear on the certification exam. Let's start preparing for the AWS Solutions Architect Associate C03 certification. Today's lecture will provide a comprehensive overview of AWS services that will be included in the exam. Before looking at AWS services in general, it is necessary to understand the AWS Tree-tier architecture. AWS Tree-tier architecture is divided into 3 parts: presentation tier, logic tier, and data tier. Those who have experience with web development will probably be familiar with the concept of this 3-tier architecture. First of all, you can think of the presentation tier as the front end and the logic tier as the back end. You can understand the data tier as a database. Let's assume that we access a website. Then we will access the website through some URL using HTTP or HTTPS. You can see that you are accessing it through this presentation tier. certain URLs need to be handled through DNS server, and AWS provides this functionality in Route 53. When you connect and need to be redirected to a specific page, there may be endpoints that need to be allowed. Let's say you've reached the website and you are trying to log in. Then you need to enter your ID and password to check if you're logged in. In order to do that, you need some kind of server or serverless resource. That's the logic tier. In AWS, you can probably use EC2 or AWS Lambda. At this point, we would have put in an ID and a password to check if you're logged in. In the data tier, whether the password and ID are correct or not will be checked, based on data already stored in the data tier. The data in this data tier can be in RDB format, the Amazon RDS, or in NoSQL format, DynamoDB. If you understand this overall three-tier architecture and then study AWS services, you will be able to understand AWS services quickly and more systematically. As I explained in Lecture 1, there are 12 major service topics that we need to know to obtain the AWS Solutions Architect Associate C03 certification. Among them, topics 1 to 5 are the most frequently appearing topics on the exam. We studied the three-tier architecture in advance. Among the three-tier architecture, the part corresponding to the logic tier is the compute, container, serverless part. And the part corresponding to the data tier is the storage and database. And in our presentation tier, we will cover the part about networking and content delivery. If we want to utilize this architected software in a more supplementary and robust way, the security, identify, and compliance parts will be important. So we are going to mainly cover these 5 service topics. This is a service topic map that summarizes 12 AWS service topics that are included in the exam scope. As you know, AWS services are so vast that even if you are only aware of what specific AWS services do, you can significantly increase your exam accuracy rate. In the following lectures, we will examine the services in detail, focusing on the content that will appear on the exam by service topic. First, let's briefly examine each service topic one by one to understand the overall meaning. First of all, in Compute Container Serverless, EC2 is the most important service. It is a server provided in the form of IaaS. When it comes to EC2, you need to understand the 4 pricing plans that vary by EC2 type. You also need to understand the auto-scaling settings for high availability of your service. We will look at other services one by one in later lectures. There are services that allows you to use AWS as a private cloud such as AWS Outposts and AWS Trans 5G Edge Cloud such as AWS Wavelength, and container services such as ECS and EKS. There are also serverless services that users can use in the form of PaaS without setting up the server such as Lambda, Fargate, and Appsync. Next service topic is storage. Among AWS storages, S3 is the most representative storage. S3 can be used cost-effectively by dividing storage and managing it according to the usage cycle. Charges vary depending on the storage type. The lower the storage fee, the higher the traffic cost. Data with a long usage cycle is not used frequently, so it will be cost-effective to store it in S3 Glacier. There are also services that centrally manages backups, such as AWS Backup, and EBS, a storage that is used together with EC2. There is also EFS, which enables high-speed data transfer using NFS protocol, and a file server service, FSX. We will also learn about Storage Gateway that connects to on-premises device as well. The third service topic is database. Databases can be broadly divided into RDB, relational database, and NoSQL. There is also a ledger DB and a data warehouse DB for data analysis. If we look at AWS services by database type, first there is Amazon RDS, which is an RDB. Amazon RDS is a database managed by AWS that supports MySQL, PostgreSQL, Oracle, and SQL Server. And there is Aurora, a fully managed RDB built by AWS that is compatible with MySQL and PostgreSQL. There is also a service that provides Aurora in a serverless form. NoSQL DB is a document DB that handles semi-structured data such as JSON and XML. There is also DynamoDB, a high-speed key-value database. Elasticache is compatible with Redis. Keyspaces is compatible with Cassandra. And there is also a GraphDB Neptune. QLDB is a ledger DB served by AWS. For data analysis, there is AWS Redshift as a data warehouse service. We will look into the details during the lecture on the relevant service topic. The fourth service topic is about networking and content delivery. Basically, networking operates on top of the region and AZ, an AWS global infrastructure explained in the previous lecture. Questions that ask about routing and CIDR also appear frequently in the exam, so it is important to familiarize yourself with them. The most important concept in AWS networking is VPC, a virtual network. You should also know the difference between a subnet, which is a smaller network unit than a VPC, an internet gateway, and a NAT gateway, which enables external internet communication. Also, to set up network security, you need to have a basic understanding of NACL and security groups. Additionally, there is AWS Shield and AWS WAF. You also need to understand VPNs to connect on-premises or VPCs, and a service called AWS Direct Connect that creates a dedicated line between AWS and on-premises. There is also AWS Transit Gateway, a service that integrates VPC connections, and AWS Private Link, which sets up endpoints for VPCs. There are three content delivery services: CloudFront, a content delivery network CDN service, Route 53, an AWS DNS service, and AWS Global Accelerator, which reduces latency by quickly transmitting content using high-speed networks. Finally, there is the Elastic Load Balancing ELB service, which acts as a load balancer that can adjust traffic to ensure high availability. We will look into the details during the lecture on the relevant service topic. The fifth service topic is about security, identify, compliance. Security-related services are services that help with firewall management and cloud security. There are AWS Firewall Manager, AWS Guard Duty, Amazon Inspector, and Amazon Messi. In the Identify section, there are services for authentication, and IAM is the most important service for AWS authentication. IAM is a concept that applies to other public clouds as well. All controls in AWS are managed by IAM. IAM has a user, group, and role system. Key management services include AWS Cloud HSM and AWS KMS. Compliance includes services that help with security audits such as AWS Artifact, AWS Audit Manager, and Amazon Detective. We will also look into more details in the lecture on the relevant service topic. These 5 service topics are the most frequently tested topics in the exam. We recommend you to check the FAQs for each service within the 5 service topics. We will quickly look at other service topics as well. The 6th service topic is management and governance. These are services for making good use of the software we have architected. After we design the software, there are DevOps-related services to automate deployment, and there are services that need to monitor them. There are support systems in AWS, and this support system helps you to make sure that your architecture is good or get help. You can also manage licenses or configs. AWS also provides governance tools, and one of them is AWS Service Catalog. We will explain the details of each service during the lecture on the relevant topic. The seventh service topic is migration and transfer. This topic covers services that can help you migrate to AWS or transfer data to prepare for failures. There are terms you should know in this service topic. RPO refers to Response Point Objective, and RTO means Response Time Objective. These are terms that you should try to understand while understanding AWS services. The eighth service topic is application integration. Application integration on AWS is a set of services that enable communication between decoupled components within microservices, distributed systems, and serverless applications. You need to understand how these services are used. The ninth service topic is analytics and machine learning. It is one of the hot topics these days. In the analytics sector, there are services for streaming real-time data and services that support big data Hadoop clusters. There are services provided in the form of data warehouses and workflow services that automate these data pipelines. AWS also provides services that support analytics and data governance services that can govern these analytics data. Marketplace services allow you to access data created from analytics projects. AWS provides different types of machine learning services as well, but we will discuss detailed information about the service in the lecture on the relevant service topic. The 10th service topic is related to developer tool and front-end web mobile. Among the developer tools, there is a service called AWS X-Ray, which provides distributed application tracing and debugging services. Also, AWS offers a variety of tools and services to support the development workflows of native iOS, Android, Reactive Native, and JavaScript developers. It supports developers who are new to AWS to easily develop, deploy, and operate applications. It is also a service that automatically scales from prototype scale to support millions of users based on the speed and stability of AWS infrastructure. For more details, please refer to the lecture on this particular topic map. The 11th service topic is the media services topic. AWS has media services that enable you to quickly and easily create, transform, and deliver digital content across any cloud. We will learn about media services that are provided on a pay-as-you-go basis and media services that allow you to produce creative projects. The 12th service topic is AWS Cost Management. AWS Cost Management tool helps you understand your AWS costs and usage. There are a variety of AWS cost management tools that help you access, organize, understand, control, and optimize your costs. So far, we have looked at AWS services that cover the entire test scope. There may have been unfamiliar terms while listening to the lecture, but the contents covered are essential to understand, so please look them up in your own time and make sure to understand them before moving on. In the following lectures, we will examine each service topic one by one based on this service topic map, and also solve example problems. If you understand the AWS service names and what role they play, you will be halfway to getting certified. If you study by expanding on what you have learned through FAQs, papers, and problem solving based on this map, you can quickly obtain the certification. This concludes the third lecture. In the next lecture, we will cover the first service topic, Compute Container Serverless topic, in detail. Let's start preparing for the AWS Solutions Architect Associate C03 certification. Today, in the fourth lecture, we will learn about the first service topic, Compute Container Serverless. This is the Compute Container Serverless service topic map. Let's learn about them one by one in order. First is EC2, the most frequently used service in AWS. The full name of EC2 is Elastic Compute Cloud, and it is an IaaS service that provides servers. If we use a server in an IDC center, we will need a server rack, network infrastructure, and an OS for the server. AWS will set up this infrastructure and even a hypervisor, a software that virtualizes the server and allows it to be used separately. AWS users can be considered to be using virtual machines, VMs, that are virtualized on top of a hypervisor. On top of VM, users can install a guest OS and configure settings for scale out and availability. You can also use it by uploading the application to it. So, how do you create EC2? We need to install a guest OS, but at this point, we already have an image that has the guest OS configured. This is called an Amazon Machine Image AMI. In this case, an image is a template file that contains the virtual machine's operating system, applications, data, and settings. You also need to decide the instance type of EC2. Instance type selection allows users to select the components of the virtual machine based on their intended use. This EC2 will be located in a virtual network called VPC. You need to decide where the VPC will be located and also decide which storage volume will be connected to the EC2. Storage also has types, not just volume, and you need to set up access control to EC2 in the security group. The VPC and security group parts will be covered in detail in the networking and content delivery section, and the storage part will be covered in detail in the storage service topic section. Let's take a closer look at the Amazon Machine Image AMI. As I mentioned earlier, an image is a template file. That template will contain configuration settings for the OS and software. So when a user creates an EC2, he or she selects an image of a specific AMI. The OSs we are trying to create may be diverse. As you can see here, you can create macOS, Amazon Linux, and you can create different ones depending on the OS type or settings. The screen you see here is the screen you can select OS when creating EC2 yourself. We talked about instance types earlier. Instance types are types of EC2 computing. Each string in the type has its own meaning. In the case of English letters in front, it means an instance family. First, there is the general purpose TMMAC that we mostly use. You can choose whether it is optimized for computing or optimized for memory. The instance type may vary slightly depending on whether you want to optimize for storage or want to accelerate computing. You can identify which instance it is by looking at the English string in front. There is also generation where you can see what version this instance is, and behind the dot indicates the size. Let's take a closer look at the EC2 pricing plan, which frequently appears on exams. We said that EC2 is a service that rents IaaS servers. The type of server you rent is slightly different for each pricing plan. In the case of on-demand, it is strictly based on usage. This is the type we use when the situation is constantly changing, or we don't know how long we will use it. Next is the reserved instance. For reserved instance, you pay for 1 to 3 years in advance. This cost can be discounted by about 72% compared to on-demand. This instance is usually suitable when being used for more than 1 year. There is also a saving plan, which is a pricing plan similar to reserved instance. The saving plan also offers a 72% discount, and you pay for 1 to 3 years in advance. However, there is a big difference between reserved instance and saving plan. For reserved instance, you need to select your instance family and size in advance. However, in the case of saving plan, you can select multiple options. So if you're running a variety of services, it is recommended to choose Saving Plan. Next, we have Spot Instance. Spot Instance is an instance that can be stopped unexpectedly. That's why it is a little cheaper. You can get discounts of up to almost 90%. If you're looking for cost efficiency, you can use Spot Instance. We use Spot Instance for instances that do not have a big problem even if they suddenly stop. It is commonly used in development environment. Lastly, there is Dedicated. Dedicated is used for services where compliance or security is important. In the case of this service, it is an EC2 instance type that is used in isolation and not shared with other services, users, or other instances. So in this case, like Dedicated, a region fee of $2 is charged per hour. Let's take a look at the EC2 autoscaling feature. Autoscaling allows you to automatically add and remove servers as needed. Adding servers is called scale out, and removing servers is called scale in. For example, you can add servers or add CPUs to match CPU utilization. If you set the Amazon AMI information and conditions for adding servers in the launch template, servers will be automatically added according to the conditions. These conditions can be used for target utilization, such as CPU utilization, number of users connected, specific time zones, and when instances are not running to prepare for failures. This feature is free, and users only pay for the increased instance costs. Autoscaling feature is available for services other than EC2 as well. Let's learn about AWS Batch service among compute services. AWS Batch is a batch computing service that dynamically provisions optimal computing resources when needed, allowing you to utilize resources as efficiently as possible. When we usually think of batch scheduling, we often think of cron jobs. AWS Batch is a service that can provide this cron job as an AWS service. When we do batch scheduling, we also need to consider the resources of the server, and AWS dynamically provisions those resources. So, AWS provides a service that allows us to run batches without having to manage batch computing software or servers ourselves. This will reduce the administrative burden. It also provides the option to save on your budget by using cost-effective Spot Instance. Please see the FAQ for more details. First, Elastic Beanstalk is a computing resource that automates capacity, load balancing, scaling, and status monitoring. It is a PaaS-type service. Developers simply upload their applications, and Elastic Beanstalk manages the deployment process. Compared to EC2, it can significantly reduce server operation and configuration operation overhead. This service can be useful for small companies that lack infrastructure personnel. Please see the FAQ for more details. Next, let's learn about AWS Outposts. AWS Outposts is a service that allows users to run AWS-like services in their on-premises environments. In other words, you can think of it as a service that provides AWS as a private cloud. A set of server devices that can be installed in a data center is provided, and services such as EC2, ECS, RDS, and S3 are made to operate inside. By installing it in your data center and connecting it to AWS over the internet, you can use AWS Outposts as AWS New Flexible AZ. These services can be used for services where security is important and data should not be transferred to external servers. Let's learn about VMware Cloud on AWS for migrating and optimizing VMware-based workloads to AWS. VMware is a traditional virtualization solution. This is a solution that is usually installed on an on-premise server to provide virtualization services. This can be migrated to AWS Services, which is the oldest cloud provider with extensive experience supporting large VMware customers. AWS provides proven migration and modernization options to simplify your transition to the cloud. AWS provides purpose-built services and programs for VMware workload migration. This AWS VMware workload migration includes options for modernizing to containers and serverless or moving to managed services. For more detailed information, please refer to the official website. Next is AWS Wavelength. AWS Wavelength is a 5G edge computing infrastructure. It is a service that combines the high bandwidth and ultra-low latency of 5G networks with AWS compute and storage services to support innovative applications. It is ideal for high-performance mobile applications that require ultra-low latency, such as game streaming, AR, and VR services. It is also suitable for enterprise applications that require low latency, such as IoT, live media production, and industrial automation. AWS Wavelength enables image and video recognition, inference, data aggregation, and responsive analytics near the data source. Before we look into AWS container services, let's take a look at what containers are in the cloud. A container image is something that runs based on a file that predefines which application to run. As you can see in the picture, this is the part that the user is in charge of. The most well-known solution for managing container runtimes that can create these container images is Docker. If this is your first time hearing about Docker, it is strongly recommended that you search for it at your own time and study it. Containers are much lighter and faster than server virtualization. This is because there is less content contained within the container than in virtual server. If you are running a virtual server, you will need an OS, middleware, and applications. So the virtual server image contains all these files. On the other hand, containers are lightweight compared to virtual servers because they only contain the dependency packages required to run the application. Also, virtual servers are like regular servers in that they start with middleware and applications running after the operating system starts. On the other hand, containers run applications directly, so the overall speed of the application execution is fast. The processing speed is also faster than a virtual server as there is no overhead for the OS. Once a container image is created, it can be used immediately on other servers. There is an advantage in that you can use the container set during development or the libraries used as they are. These container images can be exported or imported and stored using a container image repository. One thing to keep in mind when using containers is that when the container terminates, the content stored inside it disappears, so you need to mount the directory of the host server where the container will run and save the work content. Let's find out how the container technology we looked at can be implemented as a service in AWS. AWS container services include Amazon ECS, EKS, and ECR. First, Amazon ECS is a fully managed container orchestration service that simplifies running and managing Docker containers. Amazon EKS is a managed service that makes it easy to run Kubernetes on AWS. Finally, Amazon ECR is a secure managed Docker container repository that makes it easy for developers to store, manage, and deploy container images. Some of you may be unfamiliar with the terms container orchestration and Kubernetes. When operating an actual service using containers in an environment such as MSA, each function is often separated into containers and multiple containers are combined and used as a single system. If you try to manage all containers separately, the management burden will be enormous. Therefore, utilizing container orchestration tools can reduce operational load. Kubernetes is an open-source solution that handles this orchestration. On the next pages, we'll go into a little more detail about how ECS, EKS, and ECR work. We learned earlier that AWS services related to containers include ECS, EKS, and ECR. The biggest difference between ECS and EKS is whether AWS or Kubernetes handles the container orchestration function. ECR is a container image registry. This allows users to manage their defined container images in AWS and easily deploy them to ECS and EKS. Each container is included in a node. This node can be considered a server that runs containers. This server can utilize EC2 and Fargate. We will discuss Fargate in detail later. Before looking into AWS services related to serverless, let's find out what serverless is. Serverless doesn't mean there are no servers. Serverless in AWS means that there are no servers for users to manage, as the company manages physical servers and server-related infrastructure. With serverless, users can simply focus on logic. The representative AWS service for the serverless service is AWS Lambda. AWS Lambda is an event-driven serverless computing service that can run code for virtually any type of application and back-end service without provisioning or managing servers. Users using Lambda simply provide code in one of the language runtimes supported by Lambda. Runtime languages provided by Lambda include Python, C#, Java, and PowerShell. Users can write any function they want in Lambda and use the function when needed. Lambda provides a code execution environment that is automatically triggered by events. To implement this functionality, SNS and SQS is widely used in services. We will cover this in detail in the application integration topic. When we learned about container service earlier, we learned that the server in charge of nodes in ECS and EKS can be set to Fargate. Let's learn about this AWS Fargate service. As a serverless service, Fargate manages server infrastructure on AWS. So by utilizing Fargate as a node, you can use ECS and EKS more conveniently and with less operational overhead than by utilizing EC2. However, Fargate is slightly more expensive than EC2, so you should consider cost effectiveness when choosing it. AWS Appsync is a serverless, fully managed GraphQL service. Appsync simplifies data communication between client applications and servers. GraphQL is a carrier that allows clients to request and receive only the data they need. AWS Appsync helps you easily create and manage these GraphQL APIs. For example, let's say you have a library mobile app. Users want to view information about books and authors. When using a REST API, you may need to call two different endpoints to get book information and author information. GraphQL allows clients to request all the data they need in one request. The service that manages this serverlessly is AWS Appsync. Let's solve a practice problem related to what we learned. A company wants to reduce the cost of its existing three-tier web architecture. The web, application, and database servers are running on Amazon EC2 instances for the development, test, and production environments. The EC2 instances average 30% CPU utilization during peak hours and 10% CPU utilization during non-peak hours. The production EC2 instances run 24 hours a day. The development and test EC2 instances run for at least 8 hours each day. When development and test instances are not in use, the company wants to implement automation to stop. The question is, which EC2 instance purchasing solution will meet the company's requirements most cost-effectively? The important thing here is the cost. Let's look at them one by one. First of all, for production, which instance is the most appropriate? It needs to run 24 hours a day. It won't turn off, and for now, you can assume that it will continuously be used. It would be cost-effective to get a 72% discount through the reserved instance. In cases like testing and development, it seems like it would be suitable to use Spot, but the company wants to turn it off when not in use. Then, using on-demand would be more suitable than Spot. It is a pay-as-you-go model, So for production, a company should use reserved, and for test and development, it should use on-demand instances. Therefore, B is the correct answer. Here's the next problem. A company is designing an application. The application uses an AWS Lambda function to receive information through Amazon API Gateway and to store the information in an Amazon Aurora PostgreSQL database. During the proof of concept stage, the company has to increase the Lambda quotas significantly to handle the high volumes of data that the company needs to load into the database. A solutions architect must recommend a new design to improve scalability and minimize the configuration effort. Which solution will meet these requirements? First of all, you need to use a Lambda function. Lambda functions, as we learned before, are a serverless solution. There is a Lambda in the front end, and this is loaded into the Aurora database. Now, the important thing here is that this configuration effort must be minimized. Then, it should be done as serverless as possible. Let's check the services in the options below. There is Lambda and EC2 instance in option A and DynamoDB in option B. Then in C, there is Lambda and Amazon Simple Notification Service. And in D, there is Lambda and Amazon Simple Queue Service. So we need this configuration serverless to reduce the effort. Then this EC2 instance will be heavy. The question said that we will use PostgreSQL database, but there is DynamoDB in B. Then there are only two options left. When using Lambda functions, should a company use SNS or SQS? Since the question mentions about Lambda quota, we should use a queue service together with this volume to process it sequentially. So the correct answer would be D. You can check the services like this. Delete the unrelated services first, and then find the option that combines the related services that meet the requirements asked in the question. Here is the next question. A company wants to use Amazon Elastic Container Service, Amazon ECS clusters, and Amazon RDS-DB instances to build and run a payment processing application. The company will run the application in its on-premises data center for compliance purpose. A solutions architect wants to use AWS Outposts as part of the solution. The solution architect is working with the company's operational team to build the application. Which activities are the responsibility of the company's operational team? AWS Outpost is connected to an on-premises. The on-premises part must be handled by the operational team. So you will need to provide the hardware for that on-premise server. So in A, you need to take charge of the REC, the hardware part of the outpost. In B, the hypervisor storage system and the part that runs AWS services on the outpost is done in AWS. So this is not one of the answers. In a data center environment, physical security and access control are required, and this is the responsibility of the operational team. The part that enables the outpost infrastructure to be placed on the outpost rec is handled by AWS. The physical management part is handled by the customer. The part about migrating ECS clusters and managing events is handled by AWS. So to summarize, the customer should take care of managing the physical hardware. So the answers would be A, C, and E. Here's the last question. A solutions architect is implementing a complex Java application with a MySQL database. The Java application must be deployed on Apache Tomcat and must be highly available. What should the solutions architect do to meet these requirements? Let's take a look at each of the options that a solution architect should offer. When you see a problem, you should check the services first. Let's think about which one reduces overhead the most. AWS Lambda, Amazon API Gateway, AWS Elastic Beanstalk, Amazon Elasticache, and Amazon EC2. Lambda is serverless, but Lambda is not managed by the OS. Elasticache is DB, so we remove A and C. Then there is Amazon EC2 and Elastic Beanstalk, which are complex Java applications. To reduce overhead, we need to offload more parts to AWS. Amazon EC2 is IaaS and Elastic Beanstalk is PaaS. So the correct answer is B. We need to reduce our overhead as much as possible. This concludes the fourth lecture. The next lecture will cover the second service topic, storage. Let's start preparing for the AWS Solutions Architect Associate C03 certification. This is the fifth lecture and we will learn about the second service topic, storage. This is a storage service topping map. First, we will learn more about S3, the most widely used object storage in AWS. Next, we will learn about EBS, EFS, FSX, and about AWS Backup Service, AWS Storage Gateway. Before looking into AWS storage services, let's first look into storage types. Storage includes file storage, block storage, and object storage. File storage is a way to store and manage data in file units. It is a storage that is accessible through the file system and where files can be identified using file paths. The advantages are that it is easy to use and maintain and is compatible with existing applications. However, the downside is that it can be inefficient in handling large amounts of data, and it is subject to limitations of the file system. Block storage is a method of storing data by dividing it into fixed-size blocks. Each block has a unique identifier, and data is read and written in block units. The advantages are high performance and scalability. It will also allow for quick access to data, so it is suitable for high-performance applications such as databases. However, the downside is that since files are divided into blocks, management and setup can be complicated. Next is object storage. Object storage stores data as objects, and each object has a unique identifier and metadata. Its advantages include near-infinite scalability and easy data management via metadata. This type of data storage is ideal for cloud storage services. However, the downside to this is that the delay in time can be long. Also, data updates may be inefficient. We learned about storage types earlier. Let's learn about S3, AWS Object Storage. S3 is an object storage and is not actually a folder structure, but the management console displays objects as if they were folders. The /string works as a delimiter. S3 has high durability and is replicated to 3 or more AZs by default for disaster recovery. You can store an infinite number of objects in a single bucket in S3, but each object cannot exceed 5 terabytes in size. S3 consists of key, object, and bucket. If you look at the path of S3, there is S3 in the front and the bucket name in the back. It also consists of a key that combines a prefix and an object name. S3 usage types are divided according to the frequency of use of objects stored in S3. This S3 usage type is called a storage class. Let's take a look at the storage classes one by one. First, S3 Standard is the most basic type. It is used when frequent object access occurs and is basically replicated to 3 or more AZs. Next is standard IA. Standard IA has less frequent use of stored objects than standard. This type also replicates objects to 3 or more AZs by default. Next is one-zone IA. Like standard IA, objects are accessed less frequently. However, in this type of case, it is not replicated to 3 AZs, but only to 1 AZ. From standard to IA and one zone, the cost decreases as you go down. Next is intelligent tiering. We measure the usage frequency of objects stored in S3. Currently, if you use the storage class without knowing the details, AWS automatically checks the usage frequency and converts the storage class. This storage class also replicates objects to 3 AZs by default. These storage classes are split for cost efficiency. You should check the usage frequency or availability of the object and select the storage class to use. Here are the 3 Glacier storage classes. The Glacier storage class is used for archiving rarely used objects. Let's take a look at them one by one. First, in the case of Glacier Instant Retrieval, it is used for objects that need to be immediately retrievable after archiving. In Flexible Retrieval, it is used for storing objects that can have slightly longer lookup delay than Instant Retrieval. Finally, in the case of Deep Archive, archiving is done more deeply, and objects that require longer retrieval times are stored. The lower you go, the cheaper the storage costs become. So we can divide this Glacier storage class by frequency of use even if we archive it. Next, let's learn about S3 Lifecycle Management. S3 has a lifecycle setting function. For example, there may be an object that is used frequently when first used, but then becomes less frequently used after a month or so. And after a year, there may be objects that need to be archived. For this purpose, S3 provides a lifecycle setting function. The lifecycle setting feature allows you to move to a lower cost storage class after 1 month, and to a Glacier storage class for archiving after 1 year. One thing to keep in mind here is that once you move to the lower level class, you cannot return to the standard class. Next, let's take a look at S3 versioning. S3 changes all the change history of objects stored in a bucket. There are version control settings you can manage. Setting up version control allows you to capture the history of all changes made to an object. Version control settings can be set per S3 bucket and not per object. As you can see in the figure, for example, when an object is added to a bucket, the bucket version in S3 is reversioned to version ZZZ. Also, if an object in the bucket is deleted, you can mark it for deletion by reversioning it. Then the user will not see that object in that bucket. However, if you want to restore the object in the bucket, you can restore the object again by reverting the version of the bucket to a previous version. Let's learn about S3 replication. S3 replication includes same region replication, SRR, for replication between the same region, and cross-region replication, CRR, for replication to other regions. This replication is possible only when versioning is enabled. Replication is especially used when preparing for a situation where the whole region fails. Let's take a look at S3 access control. How can we handle S3 access control? First of all, there are 4 main options. You can first manage it with IAM. This is a method of controlling access to S3 resources by granting or restricting permissions to users or groups. There is also a method called S3 bucket policy, which is in the form of a JSON document. You can specify policies as JSON documents that set access permissions to S3 buckets and objects. Another way is to block public access, which prevents public access to your S3 buckets and objects to prevent accidental exposure. For example, when setting up an IAM policy or a bucket policy, there are cases where the settings are incorrect and the bucket is accessed publicly. To prevent this in advance, there is an option to block public access for documents that absolutely require security. The fourth method is the pre-signed URL method, which allows you to create temporary URLs that allow access to specific S3 objects for a limited time. This will be useful for sharing with others. IAM policy and bucket policy will be covered in more detail in the Identify and Compliance Service topic later. Let's take a look at S3 data encryption. There are two main types of S3 data encryption. There is server-side encryption and client-side encryption. Let's take a look at them one by one. First is server-side encryption. When performing server-side encryption, if you use an encryption key managed by S3 or a KMS, Key Managed Service Key, you can make a request like this and receive encrypted data as shown in the figure. Another encryption method on the server side is to encrypt data using a key transmitted from the client. In this case, when the user makes a request to the server side, the request must be made along with the client-side data key. In this case, access should only be via HTTPS. Next, let's learn about client-side encryption. This method completes encryption on the client side and then transfers it to S3. The encryption key is not transmitted to AWS. In this case, you must manage the key lifecycle entirely on the client side. Next, let's learn how to host a static web using S3. If you have HTML, CSS, or JavaScript files in an S3 bucket, you can create a static website using them. You can create a website like this with a bucket name and region name. Access management for this website can be done by granting access rights to specific users through bucket policies or ACL. If you need to use HTTPS at this time, you need to design it by placing CloudFront in front of S3. This part will be explained again when you learn about CloudFront. Next, let's learn about Amazon EBS, a block storage. EBS is a block storage service used with EC2. Simply put, you can think of it as playing the same role as a hard disk or SSD. When used with EC2, EBS continues to incur charges for the amount allocated because it stores data even when EC2 is stopped. EBS also stores data logs and configuration information for EC2 applications. By default, one EBS volume is attached to an EC2 instance, but it is possible to attach additional volumes. EBS volume types include SSD, IOPS SSD, and cold HDD, and you can choose according to your purpose. EBS also provides snapshot and backup capabilities. This will help you keep your data safe and recoverable. Next, let's learn about EFS, a file storage. EFS is a file system that uses NFS v4 protocol. This storage supports petabytes and provides 99.99% availability. It also provides storage-based auto-scaling capabilities, allowing you to automatically adjust capacity based on usage. Next, let's learn about Amazon FSx. FSx is also a file storage. FSx offers two main file storage options. The first is FSx for Windows File Server. This service provides file storage using the SMB protocol. The SMB protocol is a file-sharing protocol commonly used in Windows environments. It is available for Windows as well as Mac OS. It also supports Microsoft AD, Active Directory. Second is FSX for Lustre, a service that provides file storage using a high-speed Lustre file system. The Lustre file system is a file system suitable for high-performance computing environments. Next, let's learn about AWS Backup, a service that supports backup. As the name suggests, AWS Backup is a service that backs up data from storage such as AWS EBS, EFS, FSX, and databases such as RDS and DynamoDB. When you set up backup roles, backups are automatically performed and stored in S3, providing high availability and durability. The service is cost-effective, fully managed, and provides policy-based data protection. You can also audit and report on compliance with our data protection policies. You can centrally deploy data protection policies through AWS organizations. It also allows you to configure, manage, and control backups across your AWS accounts and resources. Next, let's learn about AWS Storage Gateway. Storage Gateway is a service that allows you to access cloud storage from on-premises. It provides low latency performance by caching frequently accessed data on-premises. It can also optimize data transmission, transmitting and compressing only changed data. It can be integrated with CloudWatch and CloudTrail, including Amazon S3, FSX, IAM, and KMS. Let's try solving a practice problem related to the service topic that we learned. This question is related to S3 storage classes. Let's first read the question. A company is storing backup files by using Amazon S3 standard storage. The files are accessed frequently for 1 month. However, the files are not accessed after 1 month. The company must keep the files indefinitely. The question asks which storage solution will meet these requirements most cost-effectively. We learned that we can configure to change the storage class. So, it seems like we need to take a closer look at options B, C, and D with the S3 lifecycle configuration. The question also said that the company is currently using S3 standard. Then, we can see which storage class to move to from S3 standard through this lifecycle configuration. The data will not be accessible after a month. If you don't have access, you can choose the cheapest option, but if you do need access, you can choose a storage class that takes a long time to retrieve data. Glacier Deep Archive is the cheapest option, and if you do get access to it, it takes a long time to retrieve. You have to choose the cost-effective option, so the correct answer is B. Let's solve this problem as well. This question is related to the use of EBS and EFS. First, let's read the problem. A company is hosting a web application on AWS using a single Amazon EC2 instance that stores user-uploaded documents in an Amazon EBS volume. For better scalability and availability, the company duplicated the architecture and created a second EC2 instance and EBS volume in another AZ, placing both behind the application load balancer. After completing this change, users reported that each time they refreshed the website, they could see one subset of their documents or the other, but never all of the documents at the same time. The question asks what solutions architect should propose to ensure users see all of their documents at once. At this point, you should know that EBS is connected to only one EC2. It seems like this issue can be solved by having two EC2 applications sharing one storage. If you want to share a single file, you can use EFS file sharing storage. So you should use EFS instead of EBS. The correct answer is C. This is the last question. A company runs multiple Windows workloads on AWS. The company's employees use Windows file shares that are hosted on 2 Amazon EC2 instances. The file shares synchronize data between themselves and maintain duplicate copies. The company wants a highly available and durable storage solution that preserves how users currently access the files. The question asks what a solutions architect should do to meet these requirements. First of all, we said that we are using our Windows file sharing system. When you think of Windows file sharing system, the service that comes to mind is FSX for Windows File Server. That service is in option C. Let's read option C to see if it's the right solution. It is using Amazon FSX for Windows File Server and multiple AZ configuration for high availability. The company has asked for a solution that increases availability and continuity, so including multiple AZ configuration would be a solution to that. So the correct answer would be C. If you find related services first, you can find the answer more quickly. This concludes our lecture. The next lecture will cover the third service topic, databases. Let's start preparing for the AWS Solutions Architect Associate C03 certification. Today, in the sixth lecture, we will cover the third service topic, the database. First, let's look at the database service topic map. Databases are broadly divided into 4 types: RDB, NoSQL, LedgerDB, and Data Warehouse. Let's take a closer look at the services provided by AWS for each database type. Before looking at AWS services, let's first understand database types. There are 4 types of databases. Let's take a look at them one by one. First of all, we have RDB, which we are very familiar with. When it comes to databases, RDB is traditionally used. Many people have used RDB at least once. RDB is a relational database, and data can be combined through joins between tables. For RDB, services provided by Amazon include Amazon RDS and Aurora DB. Next is NoSQL. NoSQL has a more flexible schema structure compared to relational database. NoSQL has database in document, graph, key value, and wide column formats. First, in the case of document database, it is a database that can use documents such as JSON or XML as a database. Among AWS services, services such as DocumentDB can support document database. Also, in the case of GraphDB, it is a database that has strengths in representing relationships. It is a database commonly used in social networks. AWS supports graph databases with a database called Neptune. There is also a database in key value format. It is a database for high-speed processing. AWS services that support key value databases include DynamoDB or Elasticache. Next is a database in wide column format. Wide column can have different columns for each row. You can use it a little more flexibly. The AWS service that supports this database is Keyspaces. The next database type is a ledger database. A ledger database has something called a journal, which allows for the history of incoming transactions to be managed. This journal can only be added to and not be deleted. This ensures the reliability of this change history management. This is a type of database that is widely used in places where change history is important, such as banking or insurance transactions. AWS provides this database format as the Amazon Comprehensive Ledger Database. Next is the data warehouse. A data warehouse is a warehouse-type data storage that helps you collect data from various data sources into a single warehouse format and analyze and utilize this data. The AWS service that supports this storage is Amazon Redshift. Earlier, we looked at database types. Now, let's take a look at the database services provided by AWS one by one. First, let's learn about Amazon RDS, an AWS service supported in RDB format. Amazon RDS is an AWS service that supports relational databases. This service uses EC2 instances. We learned about EC2 in our Compute, Container, Serverless lecture. Like EC2, RDS is also charged based on running time. When we build a database, we usually have to take care of the database software, storage attached to the database, and infrastructure. With RDS, parts of the infrastructure are handled by AWS. Database engines supported by RDS include MySQL, PostgreSQL, MS SQL, Oracle, and Aurora DB. RDS supports multi-AZ deployment to ensure high availability. AZ is an availability zone. You can replicate RDS instances in different availability zones in a region. The replicated instance is called the standby instance, and the existing instance is called the primary instance. When we access RDS, we access it using a domain name. Before the domain name fails, it is set to point to the primary instance. However, if the availability zone where the primary instance is located fails, the domain name can be automatically changed to the availability zone where the standby instance is located. This change is called failover, and this failover is automatically executed when a failure occurs. The primary and standby are synchronously replicated in this multi-AZ instance deployment. When failover occurs, the standby becomes the primary. The primary is on standby. However, this standby does not support read or write. You can think of this instance deployment as only one working. There is a cluster replication method during multi-AZ's replication. Cluster replication is to place two replicas on one primary instance. Here, only read is possible in the primary and read is possible in the replica, which is a copy. This method is replicated semi-synchronously, and this method is only provided by MySQL and PostgreSQL engines. RDS provides read replica to improve read performance. This method is similar to the multi-AZ method, but this read replica can be replicated up to 5 times. Distribution to other AZs is possible, and cross-region is also supported. This is also a method where read and write are possible on the primary instance, and read is only possible on other replica instances. These instances are replicated asynchronously. RDS also has a backup function. The RDS backup feature automatically backs up every 7 days by default and allows recovery to a specific point in time. The retention time is up to 35 days, but if you want to store data for more than 35 days, we recommend storing it in S3 for cost efficiency. And for slightly longer backup cases, we recommend using AWS Backup service. Next, let's learn about Amazon Aurora. Amazon Aurora is the RDB database service that is most often compared to RDS. It is a database that supports relational databases and can be considered a database built directly by AWS. So, the difference with RDS is that in the case of RDS, it provides engines such as MySQL and PostgreSQL, while in the case of Amazon Aurora, you can think of this Aurora database as a single database engine. You can use MySQL and PostgreSQL directly with Aurora DB without any conversion. Aurora DB is a service managed by a DB cluster. The storage connected to this database is stored in 6 copies and across 3 AZs, so it can be seen as an architecture that greatly increases availability. Let's take a look at the Amazon Aurora multi-AZs architecture that we learned earlier. As mentioned earlier, the storage connected to this Amazon Aurora database is clustered and shared. This storage is stored and replicated across 3 AZs, and the Aurora database can have multiple primary instances. This format supports multi-master. You can also place read replicas in Aurora to improve read performance. Aurora can have up to 15 read replicas, while RDS can have up to 5. Replica can automatically fail over, and this read replica can also be replicated to other regions. However, in other regions, you cannot have a primary instance and only a read replica instance can be placed. You can consider that instances in other regions only have read access. Let's take a look at Amazon Aurora's backup. As mentioned earlier, Aurora is replicated across 3 AZs, so it supports automatic recovery. In the case of DB snapshots, data from up to 5 minutes ago is saved, so you can immediately restore content from 5 minutes ago. Next, let's take a look at Amazon Aurora Serverless. Aurora Serverless refers to a service that uses Aurora in a serverless form. The case in which this serverless form is used is when the exact usage of the Aurora database is not known right away. So, there is an advantage in that you don't have to specify the instance size. You can try out Aurora Serverless before you introduce Aurora or when you launch a new service. Next, let's take a look at the NoSQL service. Let's first take a look at the document DB. When I talked about data types earlier, I said that in the case of a document database, it is a service that can directly use semi-structured data such as JSON or XML as a database. You can also use JSON format or other key value XML-like files as a database in Amazon Document DB. Another document DB that is compatible with this document DB is MongoDB. Next, let's learn about Amazon Neptune, a graph DB among NoSQL DBs. Some people may be unfamiliar with graph databases, but graph databases are useful for representing relationships as shown in the figure. Each node has its own properties, and the relationships between nodes also have properties. You can think of nodes as each object, edges as their relationships, and properties as columns defined in edges and nodes. Next, let's learn about Amazon DynamoDB, the most widely used NoSQL DB in AWS. Amazon DynamoDB is a key-value database service. It is a service that supports fast key-value database service and is often used in conjunction with event-driven services such as Lambda. As you can see in the picture, each item is partitioned through the partition key, and these partitions are replicated to 3 AZs for availability. Let's take a closer look at partition and sort keys in DynamoDB. As you can see in the picture, if you think of the entire thing as a table, each row is called an item, and the columns in the item are called attributes, and among these columns, the one that acts like a primary key in RDB is a partition key. In this data, the number can be the partition key, and the sort key can be the name. This partition key is indexed by hash value and is not sorted. This partition key must have sufficient cardinality because it is used as a unique value, like a primary key when only one partition key is used. And you can think of the sort key as a key that is used together with the partition key, and it can be used as a unique key by being linked together with the partition key. Unlike the partition key, the sort key sorts the data. You can think of it as Cassandra's column key. In this Amazon DynamoDB, there is a unit called the capacity unit. This unit is used for billing. Let's take a look at it one by one. In the case of RCU, it is Read Capacity Unit, and WCU is Write Capacity Unit. 1 RCU means that you can read 4 kilobytes per second, and 1 WCU means that you can write 1 kilobytes per second. So in cases where we are using it well and can estimate the usage to some extent, we have a billing system that pre-allocates RCU and WCU using a provisioned billing system. However, when you don't know about this usage right away, there is a billing method that charges for the RCU and WCU that actually occurred in an on-demand format. This Amazon DynamoDB is said to be a very fast key-value service, but there is a service that can cache this DynamoDB a little faster and use it. It is Amazon DAX. You can think of it as Amazon DynamoDB Accelerator. For example, after installing the Amazon DAX client on an EC2 server, Amazon DAX works with this client to perform caching. So, it is a service that connects to DynamoDB so that it can show a little faster performance. Next, let's learn about Elasticache, an in-memory key-value database. Elasticache is an in-memory key-value database that provides key-value services on memory without going to SSDs or HDDs, allowing for faster use. However, the downside is that when the instance goes down, all data is erased because the memory is volatile. So, it is a database suitable for designing databases that can be used for short-term purposes that do not require continuous data storage. It is compatible with Redis and Memcached. Next, let's learn about Amazon Keyspaces. Amazon Keyspaces is an AWS service that supports the Apache Cassandra database. The database is a NoSQL database supported in wide column format. As I explained earlier in the data type discussion, in the case of wide column formats, each row can have different columns. So, since the format of the columns is different for each row, you can have a slightly more flexible schema. Amazon Keyspaces is a service that supports Apache Cassandra as a serverless service. Next, let's learn about Amazon Quantum Ledger Database, which is a ledger database. A ledger database is used for data structures where change history is important. This change history creates a concise summary using SHA-256 encryption. This concise summary is commonly called a digest, and this digest is used as evidence of the change history and is stored in a journal. This digest can be added to but not deleted or updated. So we guarantee high reliability. We tend to use this change history for services where it is very important. It is often used for banking records, manufacturing history, or insurance processing. Next, let's learn about Amazon Redshift, a data warehouse service. A data warehouse service is a service that stores data from different data sources as a single warehouse and utilizes it for data analysis. The service that supports this is Amazon Redshift. In Amazon Redshift, data stored in S3 or RDS can be analyzed with SQL or transferred to a BI tool through Redshift. Typically, data warehouses follow a columnar storage structure. Now, let's try solving some practice problems. A company wants to provide data scientists with near real-time, read-only access to the company's production Amazon RDS for PostgreSQL database. The database is currently configured as a single AZ database. The data scientists use complex queries that will not affect the production database. The company needs a solution that is highly available. Given these requirements, what would be the most cost-effective solution? First of all, to achieve high availability, you need to go from single AZ to multi-AZ. There are 3 options related to multi-AZ, B, C, and D. As we learned earlier, there are 2 ways to deploy multi-AZ: instance deployment and cluster deployment. First, data scientists have access to read. This read has to be highly available, but as we learned earlier, the instance deployment supports standby, but the standby does not read or write. In that case, we should follow the multi-AZ cluster deployment method. This multi-AZ cluster deployment method supports 2 readable standby instances, so the correct answer would be D. Next question. The company runs an e-commerce application on an Amazon EC2 instances behind an application load balancer. The instances run in an Amazon EC2 auto-scaling group across multiple availability zones. The e-commerce application stores the transaction data in a MySQL 8.0 database that is hosted on a large EC2 instance. The database's performance degrades quickly as application load increases. The application handles more read requests than write transactions. The company wants a solution that will automatically scale the database to meet the demand of unpredictable read workloads while maintaining high availability. The question is which solution will meet this requirement. First of all, the question said that the company is using MySQL 8.0. If we use MySQL, we can try RDS and Aurora. When solving questions, you should keep in mind that if Aurora is possible, you should consider it a little more because Aurora is designed to be a bit more highly available. Aurora also supports MySQL databases. Let's take a look at relevant databases which are RDS and Aurora. Then you can choose between B and C. We need to ensure high availability, but in the case of B, it is single AZ, so that's not the answer. Let's read option C. It follows the Amazon Aurora multi-AZ deployment approach and adds the option to autoscale Aurora replicas. So the correct answer is C. Next question. A social media company wants to store its database of user profiles, relationships, and interactions in the AWS cloud. The company needs an application to monitor any changes in the database. The application needs to analyze the relationships between the data entities and to provide recommendations to users. First of all, when you think of social media and relationships, you probably think of GraphDB. GraphDB is Neptune. So if you're looking at Amazon Neptune, you should look closely at A and B. Changes can also be detected in Neptune. You don't necessarily have to use Kinesis data streams because we need to have low operational overhead. Then, simply operating as one service would be a way to reduce operational overhead. So the correct answer is B. Here's the last question. A company hosts more than 300 global websites and applications. The company requests a platform to analyze more than 30 terabytes of clickstream data each day. The question is, what solutions can be used to transmit and process this clickstream data? First of all, when you think about analyzing, you can think of Redshift. So first, let's take a look at options with Redshift. There is B and D. You should pay attention to Kinesis data streams, which is a service that we will cover later in Analytics and Machine Learning lecture. The Kinesis data streams is a service that is widely used for real-time data, such as clickstreams. So, the correct answer is option D. Option D can be used to load real-time clickstreams and then analyze with Redshift. This concludes our lecture. In the next lecture, we will cover the topic of networking and content delivery services. Let's start preparing for the AWS Solutions Architect Associate C03 certification. Today, in the 7th lecture, we will cover the 4th service topic, networking and content delivery. This is a topping map for networking and content delivery services. let's learn about the basics of networking and basic network AWS services, and then we will go into the security part, the connection part for networking, and then the DNS server and content delivery. Before looking into AWS network services, let's first look at basic network concepts. First is the IP address. An IP address is a unique number assigned to each device connected to a network. This allows each device to identify and communicate with the Internet. The most widely used IP addressing system today is IPv4. An IPv4 address consists of 4 numbers, each of which can have a value from 0 to 255. As you can see in the picture, it has a format like 192.168.1.0 for example. Each number has 8 bits. IPv4 addresses can therefore provide approximately 4.3 billion unique addresses. Next, let's learn about CIDR notation, which helps you manage and activate your network more efficiently. CIDR notation is most commonly used by appending a slash after an IP address and a number indicating the length of the network prefix. For example, it would be in the format 192.168.1.0 followed by a /16. As you can see in the picture, the meaning of the 16 is the length of the network prefix. When we learned about IP earlier, we learned that it is a number of 8 bits. The meaning of the 16 is that 16 bits are a prefix that indicates a network. The first 16 bits are fixed, and the last 16 bits can be used to allocate the IP range. Then we can create an IP with 16 bits, so 16 powered is 65,536. But here, we need to remove 2 IPs. This is because the bits that are all 0 are used as IP to represent network addresses, and the IP address with all 1 bits is a reserved IP used to represent broadcast addresses. Next, let's learn about DNS. DNS is an abbreviation for Domain Name System. DNS is responsible for converting domain names into IP addresses. It acts like a phone book for the Internet, linking domain names to servers. For example, when we type metacode.com in our web browser, DNS helps us connect by translating this domain name into the IP address of that server. By doing this, we can access our website using an easy-to-remember domain name. Next, let's learn about Network Firewall. A network firewall is a device that monitors and controls incoming and outgoing traffic on a network. This can protect your network from unauthorized access and threats by enforcing security rules to protect your network. A firewall allows or blocks traffic based on established security rules. For example, rules can be set to block connections from certain IP addresses or not allow data transmission through certain ports. This prevents unauthorized access into the network and blocks the leakage of sensitive information to the outside. Next, let's learn about routers. A router is a critical device that forwards data packets between computer networks, managing and directing Internet traffic. It is a device that determines the optimal path to efficiently transmit data from the source to the destination. First, the router receives a data packet through its network interface, and the packet contains a source address and a destination address. The router looks up its routing table based on this information. The router determines the optimal path through its routing table and then forwards the packet to the next stop. This process is repeated until the packet reaches its optimal destination. Additionally, routers periodically update their routing tables to maintain up-to-date route information. Earlier, we learned about routers. The routing table is a data table within the router that helps the router by listing the routes to the network destination. A routing table contains a route to each destination and metrics for that route. These metrics help determine the optimal path for data to travel. This allows the router to select the optimal path for data packets to reach their destination efficiently. The routing table contains information such as destination IP address or target. Next is the load balancer. A load balancer is a device that distributes incoming network traffic across multiple servers. This increases the availability and reliability of your applications. For example, when many users access a website, a load balancer distributes the connection requests across multiple servers to prevent the servers from becoming overloaded. This allows users to enjoy faster and more stable services. Additionally, the load balancer automatically diverts traffic to another server when server failure occurs, ensuring service continuity. For those of you who may be unfamiliar with the network part, we looked at the very basic concepts of networks. Now, let's learn about AWS network services in earnest. When we learned about what AWS is in the second lecture, we learned about region and availability zone. This network also needs to be understood in terms of region and availability zones. The part that is mapped to region is VPC, and there are subnets within the AZ. These subnets are private and public, and each subnet can have instances like EC2. We also have an internet gateway to access the internet from our VPC. In the case of private subnets, direct connection to the internet is not possible, and there is a NAT gateway to help with this. Let's take a look at them one by one. First, let's review the region and availability zone AZ. We learned about this in Lecture 2. AWS has a global infrastructure. This global infrastructure is divided into regions around the world, and these regions are called regions. AWS has 33 regions, and a region has multiple availability zone AZs, each of which is physically separated and has its own network and power sources. Within the region, AZs have high-speed networking, and data is transmitted in an encrypted form. So, if a specific AZ in a region fails, services can be provided from other AZs, enabling seamless services. An AZ has one or more data centers. However, from the perspective of AWS service users, since data centers are not visible, it seems that you can just focus on the concepts of region and AZ. Next, let's learn about VPC. VPC is a virtual private cloud, or virtual private network. This is a service that allows you to configure a private network in a cloud environment. To create a VPC, you must specify an IPv4 or IPv6 address range using CIDR. We learned about CIDR earlier. You can create up to 5 VPCs per account and region. For the private IP range of your VPC, you can choose from the listed 3 ranges. Next are the subnets. A subnet is a segmented network created at the availability zone level within a specific region. Subnets are created by specifying an IP range from the CIDR block of the VPC, and the IP ranges of each subnet cannot overlap with each other. Subnets allow you to manage your network by dividing it into smaller units than a VPC, allowing you to distribute network traffic more efficiently and enhance security. Each subnet has 5 IP addresses reserved and used. This includes network addresses, reserved routers, reserved DNS, reserved addresses, and broadcast addresses. These reserved IP addresses are used for internal operation and management of the network. Next is the Internet Gateway. An Internet Gateway is a critical component that allows your VPC to communicate with the Internet. An Internet Gateway must be attached to your VPC, allowing resources within the VPC to connect to the Internet. the routing table must contain a route to the Internet gateway, and this allows resources in the public subnet to communicate freely with the Internet. For example, when running a web server, the web server can download the resources it needs through an Internet gateway. Next is the NAT gateway. Private subnets that contain EC2 instances cannot communicate directly with the Internet. However, there are times when these instances need to download updates from the Internet or access external resources. In this case, a NAT gateway is used. NAT gateway is created in a specific public subnet. When an EC2 instance in a private subnet needs to access the Internet, it can communicate with the Internet indirectly through a NAT gateway. In this process, the private IP address of the instance is not disclosed and is kept secure. In conclusion, NAT gateway plays an important role in helping instances in private subnets to securely communicate with the Internet. This allows users to seamlessly perform necessary external communications while maintaining the security of our private network. We previously learned about AWS Basic Network Services. Now, let's learn about network security. First, let's learn about security groups, which are stateful firewalls to protect instances, and ENIs, and elastic network interfaces. A stateful firewall is an intelligent firewall that remembers information about inbound traffic when it receives it and automatically allows outbound traffic. Security group is a stateful firewall. Security group is required for at least one ENI or instance and plays an important role in controlling network traffic. There is no blocking in security group, only allowing. By default, all inbound traffic is blocked, and all outbound traffic is allowed. This is the screen you will see when you actually set up a security group in AWS. As mentioned earlier, all inbound traffic is blocked. So, if you want to allow a specific IP on a specific port inbound, you need to create an inbound rule. As you can see in the picture, ports, for example, HTTP port 80 are allowed. But if you want to allow all IPs coming in via HTTP, it would be 0.0.0.0/0, meaning all IPs. Also, the IP address 10.0.0.0 with /16 is the AWS private network. If you want to allow network access to a specific private net. The same goes for outbound roles. Here, you can also set the destination to another security group. Next is NACL. NACL stands for Network Access Control List. It is a network-level stateless firewall to protect VPCs and subnets. Unlike stateful firewall we saw earlier in the security group, it does not store the state of inbound traffic. So, NACL requires explicit inbound and outbound rules. This allows for more granular security settings at the network level. NACL supports both allow and deny rules. Each rule is evaluated in a given order based on its priority number, with lower numbers being applied first. The order of the rules is very important, as the first matching rule is applied. Next, let's learn about EIP and ENI. EIP stands for Elastic IP, and ENI stands for Elastic Network Interface. First, EIPs can be assigned to EC2 instances as a static public addresses. When you assign a public IP to an EC2 instance, it becomes a dynamic IP and may change each time it is restarted. Private IPs, on the other hand, do not change even if the instance is restarted. We use EIP when you need a fixed public IP. An EIP provides a fixed public IP address to an EC2 instance, which can be detached from the instance and attached to another instance. Next is ENI. You heard about ENI when you heard the explanation of security groups earlier. ENI is a virtual network interface card. ENI can be attached to EC2 instances, and multiple ENIs can be attached to a single EC2 instance. ENI can be used as a network interface endpoint. ENIs can be useful for separating network traffic between instances or managing multiple IP addresses. Next is AWS WAF. AWS WAF is a web application firewall that monitors HTTP or HTTPS requests and provides firewall functionality. This helps protect your web applications from various attacks. AWS WAF protects web applications from SQL injection and cross-site scripting attacks. SQL injection is an attack in which an attacker manipulates a database by injecting malicious SQL queries. Cross-site scripting is an attack in which a malicious script is injected and executed in the user's browser. These attacks can pose a serious threat to the security of web applications. AWS WAF allows or blocks web requests by applying web access control list rules. This allows users to set and enforce their desired security policies. For example, you can block access from specific IP addresses or block requests with specific patterns. Next is AWS Shield. AWS Shield is AWS DDoS attack defense service that continuously monitors and analyzes network traffic to protect against DDoS attacks. It monitors network traffic in real time to detect abnormal traffic patterns. AWS Shield enables customers to run applications more safely in the AWS environment and minimize service interruptions from DDoS attacks. Next, let's learn about ELB, a load balancer service. ELB is a load balancer service that plays an important role in handling TLS types and providing high availability and health checks by evenly distributing incoming traffic to multiple instances or IP addresses. ELB is divided into ALB, which is Application Load Balancer, and NLB, which is Network Load Balancer. ALB supports HTTP and HTTPS protocols and operates at layer 7 of the OSI model. It performs load balancing based on the HTTP or HTTPS request path. NLB supports TCP, UDP, SSL, and TLS protocols and operates at layer 4 of the OSI model. It performs load balancing based on IP addresses and TCP ports. We learned about AWS Basic Network Services, network security, and load balancer related services above. So, how do we connect networks? Let's take a look at each one with AWS services. First is VPC peering. As you can see from the service name, it is an AWS service that helps communication between VPCs. This VPC peering supports one-to-one connections between VPCs. However, the CIDR blocks between these VPC connections must not overlap. As you can see in the picture, 10.11.0.0 is the first VPC, and 10.21.0.0 is the second VPC, which are connected via VPC peering. And the second and third VPCs are connected via VPC peering as well. At this point, the first VPC, 10.11.0.0 and 10.31.0.0 must be connected separately. So, as you can see, in this part marked in red, and VPC3 can be connected. However, as you can see in the picture, we already have a VPC connection for 1 bands and 2 band. Therefore, when I try to connect to an IP VPC with the same CIDR block range through peering, I get an error. So you must make sure that these CIDR blocks do not overlap. This VPC peering is useful for connecting VPCs, but it is not recommended for many VPCs. I will explain more about the transit gates that connect these many VPCs later. Next is AWS Direct Connect. AWS Direct Connect is a service that connects AWS and on-premises. Have you ever heard of a dedicated line? This dedicated line is a service supported by AWS. This is a service that connects AWS and on-premises by physically installing a dedicated line. Customers can receive this dedicated line installation directly from their telecommunications provider or utilize it through AWS partner services. First, you need a VIF to actually connect the network to AWS services after laying the dedicated line. VIFs include public VIF, private VIF, and transit VIF. You need to connect by setting it differently depending on each connecting resource. Next, I will explain Transit Gateway, which I mentioned earlier while explaining VPC peering. Transit Gateway is a service to connect on-premises environment and VPCs. You can connect up to 5,000 VPCs, and you can also connect VPCs, VPNs, and Direct Connect, which we learned about earlier. This makes managing network connections a little easier. Next is VPC endpoint. It would be very inefficient for services within AWS to connect to other AWS services via the internet. So, what you can set up is a VPC endpoint. VPC endpoints include gateway endpoints and interface endpoints. Gateway endpoints include S3 and DynamoDB. S3's gateway endpoint is free. And in the case of interface endpoints, we use a format that attaches a private IP to the ENI we learned about earlier. Services that can be used in this way include S3, CloudWatch, SNS, System Manager, Kinesis, KMS, and ELB. I will explain the gateway endpoint and interface endpoint architecture in more detail later. First, this is the gateway endpoint I mentioned earlier. There are two different VPCs. These VPCs are inside the AWS network. I want to have an EC2 in a private subnet access S3 in another VPC. The gateway endpoint is used in this situation. Since EC2 is in a private subnet, you need to access the gateway endpoint through the routing table. This gateway endpoint then provides an endpoint that can connect to S3 in another VPC. So, it is a service that allows you to access resources in other VPCs without going out to the external internet. Next is interface endpoint. The interface endpoint must be used like ENI as mentioned earlier. It is a network interface card. It is attached to one of these ENIs to the EC2, and to enable the interface endpoint, you need to use a service called AWS Private Link. I want to connect to this load balance EC2 service by accessing an ELB service in another VPC. The interface endpoint is used in this case, and AWS Private Link connects this endpoint. Next is VPN. VPN is a service that is often compared to Direct Connect, which we learned about earlier. This VPN is a service that creates a virtual network which can be used like a dedicated line on top of the existing internet without actually installing a dedicated line. So, it is a service that enables on-premises and AWS services to be connected. Because it is a service that communicates over the internet, the speed varies greatly depending on internet conditions. So, it is not recommended for services that absolutely require guaranteed speed, but rather for services that require a bit more cost savings. This VPN has site-to-site VPN and client VPN. Site-to-site VPN provides persistent connectivity between a company's on-premises network and AWS VPC while Client VPN is a service for temporary device-specific connectivity. In this case, site-to-site VPN is also used when Direct Connect does not work. We have previously looked at network services in general. Now, let's learn about DNS services and content delivery services. First up is Amazon Route 53, a DNS service. So, we learned what role DNS service plays. Route 53 provides regional-level high availability in addition to this DNS role. It also helps with health checks of resources connected to Route 53. There are several routing types in this Amazon Route 53. Let's take a look at each routing type one by one. First is simple routing. Simple routing is the structure where one IP of this Amazon Route 53 is mapped. It is the simplest structure. For example, if you enter metacode.com, Amazon Route 53 converts it into an IP address and connects to the ELB with that IP address. This ELB is a load balancer. ELB distributes the incoming traffic to the EC2 instances appropriately. Next is weighted routing. This weighted routing is a routing method that distributes traffic according to a pre-selected weight, such as whether to send it to IP x point x point x point x or y point y point y point y when you input metacode.com, for example. This routing method can ensure high availability by giving less weight to places with fewer resources and more weight to places with more resources. Next is the geolocation routing method. Geolocation routing method is a service that returns the IP of the region according to the location of the user who made the request. For example, if you enter metacode.com in Korea, it is structured to connect to the ELB service in Korea. Next is latency-based routing. This is a service that connects by returning the IP of the instance within the shortest response to ensure low latency. For example, if x point x point x point x has lower latency than y point y point y point y, you can connect to x to improve your connection speed. Following is failover routing. Failover routing is routing to prepare for failures. You can think of it as routing divided into primary and standby. Normally, routing continues to primary, but if there is failure in the primary instance, routing is switched to the standby instance. Next is multi-value answer routing. This multi-value answer routing doesn't have the ELB service we saw earlier. This routing method can act like an ELB. This is because Route 53 returns a randomly connected IP. However, since this random IP returns only normal IPs after a health check, it can also increase high availability in case of failure. Next is Amazon CloudFront, a CDN service. It is a service that caches content in over 400 edge locations around the world and delivers it quickly to users. It has a great advantage in delivering static resources in particular. Amazon CloudFront, an Amazon CDN service, provides security features such as AWS Shield and AWS WAF. There may also be geographical restrictions. For example, you can set it so that cached content is only visible to certain countries. We also provide an object delegation service, which is the process of deleting or updating cached content. When caching content from multiple edge locations to serve it quickly to users, sometimes you may need to replace this cached content with a new version. The service used in this situation is object invalidation. There are several ways to invalidate objects. TTL expiration, which allows you to set the cache to expire automatically. Header usage, which allows you to only retrieve files that have changed, renaming the object and explicitly invalidating it. Let's take a closer look at CloudFront's behavioral architecture. First of all, there is the origin server. The origin server is the server that hosts the original content. This server stores contents such as website's HTML files, images, videos, CSS, or JavaScript files. Typically, you can set AWS S3 bucket, EC2 instance, HTTP, or another external server as the origin server. At this point, CloudFront is a service that caches content received from origin servers in edge locations distributed across the world, and then delivers it to users, thereby increasing transmission speed. First, when a user makes a request, CloudFront routes the user's request to the nearest edge location. This edge location is a geographically distributed data center. This edge location checks if the requested content is already cached. If this edge location is cached, it is called a cache hit. When the cache is hit, the response is sent directly to the user without requesting the origin server. However, if this edge location is not cached, it is a cache miss. When there is a cache miss, a request is sent to the origin server, data is received from the origin server, and cached again at the edge location. By going through this process, you can reduce the load on the origin server and increase the speed of content delivery. This will improve user experience and reduce server costs. Next is AWS Global Accelerators. It is a service that makes client access faster by using the AWS network around the world. This service is not a caching service. Usually, if the server we are requesting is far away, we have to go through a lot of network equipment. At this point, if you use AWS Global Accelerator to utilize AWS Network, you can increase the efficiency of this network transmission. As you can see in the picture, if you reach the AWS Global Accelerator endpoint, this endpoint is a service that can network by increasing transmission efficiency a little faster to the original server through the AWS network. This AWS Global Accelerator can assign a fixed IP address. You can connect through this IP, and since this IP passes through the AWS network, the response speed is also fast, and this can facilitate traffic management. Let's try solving practice problems. A development team has launched a new application that is hosted on Amazon EC2 instances inside a development VPC. A solutions architect needs to create a new VPC in the same account. The new VPC will be paired with the development VPC. The VPC CIDR block for the development VPC is 192.168.0.0/24. The solutions architect needs to create a CIDR block for the new VPC. The CIDR block must be valid for a VPC peering connection to the development VPC. The question is, what is the smallest CIDR block that meets these requirements? When we learned about VPC peering, we learned that the CIDR blocks of each VPC should not overlap. First, if you look at the CIDR block of the development VPC, you will see that these 24 bits are fixed in the CIDR block, and you can create an address with the remaining 8 bits. You should first remove any options that overlap with this CIDR block. If you look at option B, you see that 192.168.0.0 has the same 24 CIDR blocks. Therefore, we will exclude this option. If you look at the CIDR blocks of A and C, they are 32. This 32 means that all bits in the front are fixed. If the CIDR block is 32 like this, it means exactly this IP. However, when we set up a VPC, there must be public or private subnets within the VPC. And if the VPC has only one IP, we cannot configure an efficient network. So options A and C should be excluded. If you look at these CIDR block, it is 10.0.1.0 with 24. In this case, the development VPC and CIDR blocks do not overlap, so the correct answer would be D. Here's the next problem. A solutions architect is developing a VPC architecture that includes multiple subnets. The architecture will host applications that use Amazon EC2 instances and Amazon RDS DB instances. The architecture consists of 6 subnets in 2 availability zones. Each availability zone includes a public subnet, a private subnet, and a dedicated subnet for databases. Only EC2 instances that run in the private subnets can have access to the RDS databases. The question is asking what architecture can be considered in this situation. First of all, EC2 is in a private subnet and needs to be connected to RDS, so we need to consider the firewall level to make this connection. We said that we can set up a firewall with security groups and NACL. The components that need to be connected are EC2 and RDS instances. The service that allows you to set up a firewall at the instance level is called a security group. Now let's take a look at the options with the security group. There are 2 options, B and C. But when we talked about security groups, we said that only allow is possible. We said that deny is not possible. From that perspective, in option C, it says that the security group follows inbound traffic. It says to create a security group that allows inbound traffic from the private subnet and attach it to a DB instance. Then you can create the security group and attach it to the RDS database. So the correct answer would be C. When accessing instances like this, you should first think about security groups. Here's the last problem. A company has an on-premises application that generates a large amount of time-sensitive data that is backed up to Amazon S3. The application has grown and there are user complaints about internet bandwidth limitations. A solutions architect needs to design a long-term solution that allows for both timely backups to Amazon S3 and with minimal impact on internet connectivity for internal users. The question asks to find a solution that minimizes the impact of internet connectivity. Then it seems that Direct Connect would be more suitable than VPN. The example that mentions this Direct Connect is B. The solution that B is talking about is to design it so that you can efficiently back up your traffic by installing this Direct Connect. So the correct answer would be B. This concludes the 7th lecture. In the next lecture, we will cover the 5th service topic, security, identify, and compliance.